Hello, and welcome to Lesson 1C. I can classify points as collinear, non-collinear, coplanar, and non-coplanar, and analyze the different ways lines and planes can intersect. So today we're going to look at kind of different ways that points, lines, and planes are three basic building blocks of geometry, are three undefined terms, the way that they interact with each other. We say that three or more points, are considered collinear if they lie on the same line. And actually, when we look at the word collinear, you actually see the word line in the middle of that word. Well, and think about co-star. The word co means with or to share. So if we are collinear, then we are sharing the same line. So 3 points are considered collinear if they're on the same line. If we just take any two random points out anywhere in space, any 2 points I can always draw a line between, so any 2 points are collinear points. We have a similar concept when it comes to planes. 4 points are considered coplanar if they're on the same plane and are not on the same line, so they're not collinear. And there's actually a really cool reason for that. So looking at this diagram here I've got 2 planes. I've got this pink plane, or plane, I could call it GEO, G-E-O or EOB, and then I've got this green plane here, which I could call FAL or LIC, 2 planes. And you can see that all of the points in the pink plane are coplanar and all of the points in the green plane are coplanar. But if I had chosen points directly along this line here, like here, here, and here, do you see how those 3 points, while they're collinear, they actually lie in more than one plane? Those 3 points lie in both the green plane and the pink plane, so we can't really talk about them being coplanar. So in order to say that points are coplanar, they cannot be collinear, okay? They have to be what we would say non-collinear. So there you go. Any 3 points are always coplanar because if I take any 3 points in space, I can always fit a plane onto them. If you've ever sat on a 3-legged stool, you've actually experienced this. Did you know it's actually impossible to have a wobbly 3-legged stool? And that's because those 3 points, the 3 feet are the points, they'll always lie in one plane. So you'll never have that situation where you can rock in between the feet because all 3 of the points will be on the ground in the same plane. All right, guys, I want y'all to take a minute now and draw an example of 3 coplanar points. All right, let's keep going. Let's talk about how lines can intersect. There are 3 possibilities for how lines can intersect. The first one, which you saw loads of in Algebra 1, are parallel lines, okay? And parallel lines are lines in the same plane that never intersect because they have the same slope. And this will be on your mastery test, right? If I call this line L and this line M, notice I'm using cursive letters because we're talking about lines, I could say that that line L is parallel to line M using the symbol double lines. Okay, double lines mean parallel. My second way that 2 lines can interact is that they can actually intersect. So we would say that intersecting lines are lines in the same plane that intersect at one specific point. So they'll intersect right there. Let's call that guy point A. Now, we have a special case of intersecting lines that, again, you talked a lot about in Algebra 1, and we're going to continue talking about in geometry, and that's perpendicular lines. And perpendicular lines are lines that intersect at a right angle. And this means that their slopes are opposite reciprocals. And what does that actually mean? Well, let's say one slope is 2. Well, then the other slope, M2, would be the opposite. That means I change the sign, and the reciprocal, I flip it. So it'd be -1/2. So those are opposite reciprocal slopes. My symbol for perpendicular lines is an upside down T. So in this example over here, I could say that segment AB is perpendicular to segment DE, and I use the upside down T symbol to mean perpendicular. Another case of intersecting lines would be two lines that are actually the same line. They're two lines with the same equation. And of course, when you graph two lines with the same equation, they end up on the same line. It happens. You're not going to see it very often, but it does happen. Now, the third way that two lines can intersect is that they can be skew. And skew lines only happen in 3 dimensions because skew lines are lines that never intersect because they're on different planes. So they're not parallel, but they never actually do intersect. So for example, here we've got a lovely rectangular prism, and you can see that those two lines drawn on there will never intersect, but they're definitely not parallel. So now for your try me, I want you to go through and draw an example of each of these. All right, now let's do a couple more try me's. I want you guys to take a minute and answer these 4 questions here just to test your knowledge. I am going to go through and give some examples real quick. All right, here's some example solutions. Again, there are many right answers to these. I based all of mine around the line segment AD. So I said a pair of that 2 parallel segments could have been AD and BC. Notice they're all on that top plane, ABCD, and they never intersect. A pair of intersecting segments could have been AD and DE. They definitely intersect. A pair of perpendicular segments, which again is another type of intersection, could have been AD and DC. They intersect right there at the corner. I'm assuming that's a perfect rectangular prism. And then a pair of skew segments, AD and, ooh, no, GF is parallel. That's a mistake on my part, guys. AD and let's do EF. So pay more attention than Miss Rob to your notes. All right. Let's talk now about how lines and planes can intersect. Lines and planes can intersect in 3 ways. The first way, of course, is simply no intersection. In the case of a line that is parallel to the plane, okay? So that would look like if I have a plane and then my line is just floating up above my plane, okay? My second case would be that they can intersect at a point when a line actually passes through the plane but doesn't lie in the plane. So for example, here's my plane, and I could actually have a line that just passes straight through it at this point right here, okay? And then my third case is a line lying in the plane, in which case they intersect in a line. So that would be if I've got my plane here, and then we've just got a line hanging out on the inside. So that is how lines and planes can intersect. And then finally, we're going to talk about the ways in which planes can intersect. Firstly, of course, you have the case of no intersection when you have parallel planes. Parallel planes. And in the case of, for example, up here, plane ABCD is parallel to plane EFGH because they are separate planes. They're never going to intersect, but they're parallel. A second case is when your planes intersect in a line, in the case of your intersecting lanes, or intersecting planes. Come on, please write. Thank you. Intersecting planes. And we actually saw that back here. Back here, your green plane and your pink plane intersected on this line right here. Okay, and so those are 2 intersecting planes. And your third case is a case where your planes actually occupy the same space. So effectively, they end up being the same plane because planes are infinite, but 2 planes that are the same, that overlap in some way, shape, or form. So that's how planes can intersect. All right, guys, that's the end of lesson 1C. Go ahead and take a look at the MML, and we will talk to you in class. Thank you very much.